One way to do number 1 is by factoring out a number. So what number goes inside 30 but also 54? So as we can see from the answers, it has to be 6, right? So it can either be negative or positive. I'm going to put positive. That way I don't have to make my first number negative. Okay, so 30 divided by 6 is 5. So we write a 5. We didn't take out any m's, so we write m squared. Now, what's negative 54 divided by 6? That's negative 9. And so we can see that our answer is letter A. Now, let me show you a different way of doing this. So when I was in school, what I used to do is if the question was a multiple choice, I used to get the problem and put a number for that m. So for that m, I would put a number, whichever number you want. So for this example, let's try number 2. So get a calculator and plug number 2 instead of the m and see what you get. So using Desmos, I plugged it in, and as you can see, I got 66. Now, what I'm gonna do, since it's multiple choice, is I'm gonna plug a number 2 for all those m's in multiple choice A, B, C, and D, and see which one gives me 66. And when I plug it to A, we can see that the first one gives me 66. So right away, I know that A is my answer, and I don't have to go any further. Now, the first thing that you need to know about number 2 is that whenever you see the word product, you should know that you have to multiply. So we have the first binomial times the second binomial, which we can do by doing the box method or the FOIL method. Let's start by doing the box method first. So since it's 2 terms in the first binomial, we draw 2 columns, and 2 terms in the second binomial, we draw 2 rows. So a 4-square box. We're going to put the first binomial on top, but you can put it either on the top or on the side. And I'm going to put the second binomial on the side. And then remember that from outside the box to inside the box, we multiply. So we get m times 8m, and that equals 8m squared. Then we do the second square, negative 6 times 8m, and that's negative 48m. Third box, we get m times negative 1, and that's negative 1m. And you don't have to write the 1, but let's just draw it to make it easier. And the last box is negative 6 times negative 1, which gives us 6. Now let's combine like terms, which is the negative 1m and the negative 48m, remember, diagonal. And that gives us negative 49m. Now that we have the combination, we can write out the answer. The answer is going to be the first box, which is 8m squared, and the combination, which is minus 49m, plus the last box, which is plus 6. And that's your answer. Now let me show you how to do the FOIL method. If you don't care to learn the FOIL method, you can go ahead and move to question 3. For those who want to learn, FOIL means first, outer, inner, and last. So first you have to multiply the first terms in each binomial. So you're going to multiply m times 8m, which gives us 8m squared. Then you're going to multiply the outer terms of each binomial. So when you look at this, the outer terms are m and negative 1, which give us negative 1m. Then you're going to multiply the inner terms, which are negative 6 and 8m. So negative 6 times 8m equals negative 48m. Finally, we're going to multiply the last terms of each binomial. So it's going to be negative 6 times negative 1, which gives you 6. Now that you have multiplied the binomials, you can combine like terms, we see that -1m and -48m are like terms, so let's combine them. So -1 minus 48 gives us -49, and don't forget the m. And that gives us our answer. Now, on number 3, the expression is a monomial. Just to remind you, a binomial is an expression that has 2 terms. A trinomial is an expression that has 3 terms. And here's an example. And all of these are polynomials. But with a monomial, we can simplify the expression by using our exponential properties. Here is the STAR reference sheet that you will be provided during the STAR test as well as your unit exams. And here are the exponential properties. So the first thing that you can do is you can combine all your numbers. Since everything is being multiplied or divided, you can do this. You can start wherever you want. So I'm going to multiply and divide my numbers. So it's 10 times 4 divided by 8. 10 times 4 is 40, and divided by 8, that's 5. So all my numbers are going to give me 5. So now let's rewrite this expression. So don't forget the negative. Okay, all my numbers give me a 5, so I'm going to write a 5. And from there, I'm just going to continue writing all the variables. So x squared, y, x, y squared, denominator x, and y. Okay, let's keep simplifying. So from here on, you can either multiply the x's on top or divide the x on top with the bottom. You can choose whatever you want to do. Let's say we multiply the x's on top. Okay, so if we look at the reference sheet at the product of powers rule, it says when you multiply the same base, the base stays the same on top, right, on the numerator, and the exponents add up. So you have to add the exponents. So let's rewrite this. So when you add the exponents, you're going to get an x to the 3. That's 2 plus 1. Where did I get the 1 from? Will you see that second x? Any variable that is by itself has a 1 on top, right? So it has the exponent of 1. So 2 plus 1 equals 3. So we write x3. From there, we continue writing all the variables that we haven't used. And let's not forget our negative sign. So we have our negative, our 5, our y squared, denominator x, and denominator y. Let's continue simplifying. So now let's say that we want to multiply our numerator y's, our top y's. So we're going to use the same product of powers rule, which says we keep the base and we add the exponents. So we write the negative 5x cubed, and the y's are going to be 1 plus 2 equals y to the 3. Everything else, remember, stays the same. Our negative sign, our 5, our x cubed, and the denominator x and y. Let's continue simplifying. So let's say that we want to divide those x's. That's the quotient of power rule. When we divide same base, we keep the same base and we subtract the exponents. We're going to keep that x. 3 minus 1 equals 2. So we're going to write a 2. Remember, there's a 1 on that single x on the bottom. Everything else, we keep the same. Now let's divide those y's, which is the same quotient rule. So we keep everything the same and we subtract the exponents. So 3 minus 1 gives us 2, right? Because that y in the bottom has a 1. So 3 minus 1, 2. Now that we get here, we can't simplify any longer because there aren't any more x's or y's to combine. So this is our answer. Now, if you can do this in less steps, go ahead. I just wanted to show you step by step. But here's another way that you can do it. So again, we combine the numbers and that gives us 5. So let's write everything. Don't forget the negative. So we have the negative, the combination of the numbers, x squared, y, x, y squared, the denominator x, and the denominator y. Okay, from here, instead of multiplying, you can start dividing. So you can divide that single x with the bottom x. That's something that I would do because they would cancel each other. Let me explain why they would cancel each other. Because the quotient of powers rule says that when you have the same base and they're being divided, the exponents subtract, right? Well, that x on top has a 1, and that x on the bottom has a 1. So 1 minus 1 equals 0. So that would give us x to the 0. And isn't any number to the 0 equal 1? So in reality, whenever we divide that top x by the bottom x, we're going to get a 1. But remember, whenever we multiply or whenever we divide by 1, that 1 doesn't matter at all, right? Look, 3 times 1, what is that? It's just 3. 3 divided by 1, what is that? That's just 3. So that 1 is not going to matter. So that's why that top x is going to cancel with that bottom x right away. Okay, let's write whatever we have left. Now let's apply the same logic to the y's. That y on top is going to cancel that y in the bottom, and we're going to get left with our answer by a faster method. Now let's look at number 4. In number 4, those x's can't cancel right away like we did on 3. And the reason for that is because we have an exponent on the denominator that has to be distributed first. Remember PEMDAS, right? Exponent is before multiplication and division. So first, before we start canceling anything, multiplying or dividing, let's distribute that 2 on the bottom. So remember, every term inside the parentheses gets that 2. So the 4 is going to get the 2, the x is going to get the 2, and the y is going to get the 2. Okay, now that everything has the 2, now that the 2 has been distributed, let's simplify. So I'm going to simplify the 4 square in the bottom, which gives you 16. And I'm going to write everything else. From here, we can start simplifying. So let's start by dividing the 24 by 16. You can divide 24 by 16, but you can simplify that number. Both 24 and 16 can be divided by 8. So 24 divided by 8 is 3, and 16 divided by 8 is 2. Now let's continue by dividing the x's. Remember, the quotient of power rule says when you divide the same base, you subtract the exponents. So 3 minus 2 equals 1. So we write x to the 1. Now let's divide those y's. Using the same rule, 7 minus 2 gives you 5. So the answer is y to the 5. Can we simplify any further? We can't. There are no more x's and there are no more y's that we can combine. So then this is our answer. So problem 5 is asking for area in square feet, right? So we know that area is length times width. So that top binomial could be the length, and that binomial on the side can be the width. Okay, so then let's multiply the length times the width. So it's going to be that top binomial times that binomial on the side. And look, multiplying two binomials, isn't that just either the box method or the FOIL method? You can use whichever method you want. I'm going to use the box method. So I'm going to put that first binomial on top and that second binomial on the side. Now, since it's from the outside to the inside of the box, we multiply, right? So let's get that first box. We multiply 6x times 8x to get 48x squared. Now let's multiply that 2 with the 8x and we get 16x. We multiply the 6x times the negative 2 to get negative 12x. And the last box, we multiply 2 times negative 2 and we get negative 4. Now remember, before we write the answer, we need to combine those x's, so the diagonal line. So what's negative 12 plus 16? That is positive 4x. And now our answer is going to be that first box, which is 48x squared, that combination number, which is plus 4x, and that last number in the box, which is negative 4. And don't forget, I almost forgot, square feet. All right, number 6 says to expand the polynomial expression. So what does that mean? So you see that square? That means that, remember, when something is square, it just means that you multiply it twice. So whatever's in the parentheses, you're going to multiply it twice. So it basically is going to be the binomial times the same binomial. And isn't that just the box method or FOIL method? All right, I'm going to do it using the box method. So I'm going to put the first binomial on top and the other binomial on the side. They're the same thing, and it doesn't really matter. Now let's multiply. What's 4x times 4x? That's 16x squared. Five times 4x, that's 20x. Again, the top 4x times the bottom 5, that's 20x. And the 5 times the 5, that's 25. Remember that we have to combine those 20x's, the diagonal line, which gives us 40x. And our answer is going to be that first box, 16x squared, the combination plus 40x, and that last box plus 25. And that's our answer. Remember, your answer should be in standard form, meaning biggest exponent to smallest exponent, right? Biggest degree to smallest degree. Okay, now, there is another way to do this one. I don't know if you guys remember. If you guys remember, we learned perfect square trinomials, right? You see how that looks? That a plus b squared is a 4x plus 5 squared. So that gives us a formula, a squared plus 2ab plus b squared. So we can also do this problem by following that formula. So our a is 4x. So let's replace that a with the 4x and let's square. Guys, don't forget that the a is a 4x. It should be in parentheses. Okay? So then we do plus 2a, which is 4x, times b, which is 5, plus b squared. What was b again? B was 5. Okay, so plus 5 square. Now, let's distribute that 2. Remember, the 2 is going to go to the 4 and it's going to go to the x, making it 16x squared. We're going to combine those middle numbers, and they're being multiplied. So 2 times 4 is 8, times 5 is 40x. And the last number, 5 squared, is 25. And that gives us the answer. Okay, number 7. In number 7, when they say find the quotient, quotient means divide, right? Okay, so let's do this using the box square method. We see that the biggest degree is 2, so that means 2 columns. And the divisor is 2 terms, so that means 2 rows. So we're going to have a 4 square box. Remember, the divisor, we can put it anywhere. Let's put it on the side, just because it makes more sense that way to you guys. And remember, that first term should be the first box. Now, I want to remind you that the last box should be done at the end. That should be the very last thing you do, because sometimes there will be a remainder, right? So let's use that last box to check our work, but also to check for remainders. So since we're going from the inside of the box to the outside of the box, remember that you divide. So what's 8 divided by 4? That's 2. And then x squared divided by x, that's just x to the 1. Another way that you can think of it is you need 2 x's, right, inside the box? All right, but you already have 1 right here. So how many more do you need? You only need 1 more to get that 2. All right. Now we can find that bottom left square. So we have 2x on top and a negative 7 on the side. So when we multiply, what's 2x times negative 7? That's negative 14x. All right, this is the hardest part, guys, because you guys always have trouble combining negatives and positives. So this diagonal line, these 2 squares should give you that combination answer, which is negative 26x in this example. So you already have negative 14. How much more do you need to subtract to get to negative 26x? Think about it for a second. And the answer is 12x. Negative 14 minus 12 is negative 26. Okay, so now that we have that negative 12x, now we can figure out that top answer, that top number that gives us our answer. So negative 12 divided by 4 is negative 3. So our answer is going to be 2x minus 3. But let's check if that's the complete answer by doing that last box. So negative 3 times negative 7 is positive 21, right? 2 negatives make a positive. Now, is 21 the number we want? Let's check. It is the number we want. So that means that we're done and that this is our answer. So our answer is 2x minus 3. Okay, now let's do number 8. Number 8 asks us to simplify or evaluate. Letter A. Letter A looks like a radical, right? And that's a rule. Let's change the radical to a rational exponent. So we know that the number on the right side of the radical is going to be m. The number on the left is going to be n, and then the base is a. So we already know that the number on the right is 7, so that's our m. The number on the left, n, is 3, and the base, a, is x. So let's write that in rational form. So our a is our x, our m is a 7, and our n is a 3. And that's our answer. So looking at B, do you know what's 8 to the power of 4 over 3? Okay, so if we don't know how to do that right away, what we can do is change that 8 to a number with an exponent, right? So let's rewrite this. And we're just going to change the 8. So we want the exponent to be a 3. We want the exponent to be a number that cancels with that denominator on the other exponent. So then that means that we need to get a number that when you multiply it 3 times equals 8. If this is hard for you, you can start by just putting any number and seeing if it works. So let's try 1. 1 times 1 is 1, times 1 is 1. It's not 8, right? So then 1 doesn't work. Let's try 2. 2 times 2 is 4, times 2, that's 8. So then that's the answer. So 2 to the 3 gives us 8. So now that we simplified 8 to 2 to the 3, we can cancel those 3's, and we are left with 2 to the 4. And do we know what's 2 to the 4? Well, that's a little bit easier. Let's work it out. So we multiply 2 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is 16. Let's work on letter C. So letter C is an exponential property, right? That's the product of powers. And product of powers says when we multiply 2 bases that are the same, we only keep one base and the exponents add up. So let's keep that one base and let's add up the exponents. So we have 2 over 3 plus 5 over 3. And do you remember how to add fractions? Well, we need a common denominator. Is that denominator the same? Yes. So that means that we can add up the top numbers and the bottom number just stays. So we get 7 over 3. So our answer is going to be x to 7 over 3. And that's it. Now let's go to letter D. Letter D looks like a big exponential monster, right? But it's actually simple because do you see anything that has to be distributed? Nothing has to be distributed. So that means that we can start by dividing everything. Let's start by dividing 6 by 3. What is 6 divided by 3? That gives us 2, right? Okay, so let's write it down. Now let's go to the x's. x14 divided by x11. That's the quotient rule, which the quotient rule says whenever you're dividing the same base, you keep that base, but you subtract the exponents, right? So let's subtract the exponents. 14 minus 11 is 3. So we write x to the 3. Now let's work on y. y8 divided by y13, we keep the y and we subtract the exponents. So 8 minus 13, remember, it's top number, top exponent minus bottom exponent. It doesn't matter if the bottom exponent is bigger. Okay, top minus bottom. So 8 minus 13 is negative 5. So we write y to the negative 5. Okay? And then finally, let's work on those z's. Z to the 2 over z to the 3. We keep the z and we subtract the exponents. 2 minus 3 equals negative 1. So we just write negative 1. And that's it. There's nothing else to combine. There are no more x's, there are no more y's or z's. So, are we done? No. Remember, when you simplify, there should never be negative exponents left. No negative exponents left. Okay, so let's change all those exponents to positive. Now, if you get confused with these on how to change them to be positive or where to put them, what I like to do is first draw a line and decide what stays on top and what goes to the bottom. So that 2 has a positive exponent, so we keep it on top. That x has a positive exponent, so we keep it on top as well. But that y has a negative 5. So the way to change that exponent to a positive 5 is by flipping it. And if it's on top, then that means that now you put it in the bottom. And the same thing happens to z. Z has an exponent of negative 1. That means that you have to flip it. And if it's on top, now it should go on the bottom. And once it's in the bottom, remember, those exponents are positive now, no longer negative. So now that we have all positives, we're done And that's our answer.